Welcome to C++ for coding interviews. Before we start, let's be clear. This is a focus guide. No fluff, no engine-level features you will never use in a whiteboard interview. This is a DSA crash course combined with an interview playbook. Our goal is simple: to give you the exact tools you need to solve LeetCode-style problems fast. We will cover essential syntax, powerful STL containers like vectors and maps, and the problem-solving patterns that show up again and again. You will not just learn the code, you will learn how to communicate your approach clearly under pressure. So if you are looking for the shortest path from zero to interview ready, you are in the right place. And as promised, this is all the C++ you need for DSA interviews. Let's begin. By the end of this video, you'll gain 5 specific skills. First, translation. You will learn to stop staring at the screen and instantly break complex problems into simple logic. Second, speed. You will master the STL so you can write working C++ solutions in minutes, not hours. Third, safety. You will learn to dodge the silent killers, like integer overflow, the kind of mistake that fails strong candidates. Fourth, intuition. You will not memorize code. You will learn to recognize patterns so you know exactly which data structure to use. And finally, communication. I will teach you how to narrate your thought process so the interviewer is rooting for you to succeed. Interviewers mostly evaluate 4 things: clarity of thinking, correctness, including edge cases, time and space complexity, and communication. They do not care about fancy OOPS features, rare C++ tricks, ultra-optimized bit manipulation. Focus on demonstrating clear thinking and solid fundamentals. Interviews test problem-solving ability, not C++ expertise. Here is the solve framework you will use on every question. Step 1. Restate the problem and confirm constraints. Step 2. Walk through one example out loud. Step 3. Choose a pattern and set a complexity target. Step 4. Code, then test edge cases. Follow this flow and you will sound structured and confident. Quick performance win. At the top of main, add fast input-output. 2 lines, iOS sync with STL set to false, and sin tie to null pointer. This prevents time limit issues on large input. It is a standard competitive programming habit. The #1 silent bug in C++ interviews is overflow. A normal int breaks around 2 billion. If you are doing sums, products, or prefix sums, use long. Golden rule. When in doubt, use long. Overflow gives wrong answers without warning. For interviews, your loop toolkit is simple. Use for loops for arrays and vectors. Use while loops for 2 pointers and BFS logic. Prefer readable loops. Avoid clever shortcuts under pressure. Clean loops reduce mistakes and improve speed. Now, a major performance trap: passing a vector by value. If your function takes a vector by value, C++ copies the entire vector. That is O of n work, just to enter the function. In recursion, DP, or large input problems, this can cause time limit exceeded. The fix is pass by reference, and usually const reference. Use const vector ampersand, no copy, instant access, and const prevents accidental modification. Rule: vectors, strings, maps, sets. Pass them by const reference unless you truly need a copy. Strings in DSA are straightforward. Use the C++ string type. Avoid C-style character arrays. You mainly use size, indexing, substring, and building characters. Think of a string as a vector of characters. That mindset makes string problems easier. Now we enter the real interview weapon, STL. Your ability to pick the right container saves time and removes bugs. Vector for dynamic arrays. Unordered map for fast lookup and frequency. Map and set when sorted order matters. Stack for LIFO patterns. Queue for BFS. Priority queue for heaps and top K problems. Vector plus sorting wins a surprising number of interviews. Once you sort, problems become structured. You unlock 2 pointers, you simplify duplicates, you make greedy strategies possible, and binary search becomes easier. Always ask this question: should I sort first? Unordered map is your go-to for frequency counting and scene patterns. count occurrences, track visited, store indices, detect duplicates. If a problem asks for counts, pairs, or matching, hashing is often the cleanest solution. This container shows up everywhere in interviews. Here's the decision rule. Unordered map is fastest on average. Constant time operations, no ordering. Map is O of log n, but it keeps keys sorted. If you need ordered traversal, range logic, or sorted keys, use map. Otherwise, choose unordered map. Stack and queue cover classic interview patterns. Stack is perfect for parentheses. Monotonic stack. Next greater element. Queue is the foundation of BFS, level order traversal, minimum steps problems. Keyword queues help. Next greater points to stack. Minimum steps points to BFS. Priority queue is a heap. By default, it is a max heap. You can also build a min heap. Heaps solve top K questions, scheduling, and greedy selection. If you need the best element repeatedly, a heap beats sorting every time, especially with streaming input. Two pointers and sliding window are the most common array patterns. Two pointers often appear with sorted arrays and pair targets. Sliding window appears with subarray or substring constraints. Expand the right pointer. Shrink the left pointer when invalid. Update the best answer. Pattern recognition here is a huge advantage. Prefix sums turn repeated range work into constant time. And when you combine prefix sums with a hash map, you can solve many count subarray problems efficiently. If you see subarray sum equals k, think prefix sum plus unordered map. This also works when numbers are negative. Here is a quick decision guide for advanced patterns. Binary search on answer appears when feasibility is monotonic. Trees, graphs, and grids often require DFS or BFS. DP appears with overlapping subproblems and repeated states. You do not need to guess randomly. Look for triggers in the prompt. Now let's talk execution. During the interview, say things like, "Let me restate the problem. Constraints suggest this complexity. Let's test edge cases." Then follow a simple 14-day plan. Arrays and hashing first, then sliding window, prefix sums, binary search, then stacks, queues, BFS, DFS, trees. Finally, DP and mixed mocks. Structure beats panic. This is your pattern recognition map. Subarray or substring constraints, sliding window or prefix sums, sorted plus pair target, two pointers, minimum steps, BFS, all paths or explore choices, DFS or backtracking. Optimize minimum or maximum with monotonic feasibility. Binary search on answer, repeated states, DP. Here is the sliding window mental model. You keep a left pointer and expand the right pointer across the array. When the window becomes invalid, shrink from the left until it becomes valid again. The key is an invariant. At every step, the window satisfies the condition, then update the answer. This is the prefix sum plus hash map template for subarray sum equals k. Track a running sum. At each position, count how many times you have seen running sum minus k before. Initialize the count of 0 to 1, because a prefix itself may equal k. This approach works even with negative numbers. Binary search on answer is a strategy. You guess a candidate answer. You run a feasibility check. Then you move left or right. Look for words like minimize, maximize, capacity, days, speed, or distance. If the check becomes easier as the answer increases or decreases, binary search on answer is often the right tool. BFS is the best tool for minimum steps in an unweighted graph or grid. Use a queue. Mark visited early. Process level by level. Each level represents distance. When you reach the goal, the current level count is your shortest path. The biggest mistake is forgetting visited, causing cycles. DFS explores deep. It is used constantly in trees and graphs. In graphs, always track visited to avoid cycles. In trees, DFS powers traversals and path computations. Keep it simple. Base case early, recurse. Combine results. Clarity beats cleverness. Backtracking is DFS with decisions and rollback. Choose an option, explore, then undo it. This powers subsets, permutations, and combinations. The most important rule is undo. If you do not roll back correctly, your state becomes corrupted and your answers become wrong. DP becomes easy with the right mental model. DP is recursion plus memoization. Define the state. Define the transition. Set the base case. Identify where the final answer lives. Start small, like Fibonacci or climbing stairs, then scale up to harder problems. In interviews, state complexity clearly. Call out the dominant operation. Sorting is O of n log n. A single pass is O of n. Binary search is O of log n. Also mention space. O1 if constant, or O of n if you use a map, visited, or a DP table. This makes you sound intentional and senior. Let's close with a 60-second mock approach. Restate the problem and confirm constraints. Pick the pattern and explain why it fits. State the key invariant in one sentence. Code cleanly using STL. Test two edge cases, like empty input and maximum values. That is how you crack coding interviews. Framework, patterns, and consistent practice.